Now, if you remember during the decision tree class, right, when we saw something like this where we loaded our data set, we did some pre-processing over here, and then later on we built this decision tree. Okay, we built a decision tree like this, and then we say that if you see the tree, it's actually overfitting, right? It's overfitting because the tree has overgrown. All right, it's overgrown, right? And if you see the accuracy that we were having, right, we're having 100% on the training, but on the testing we're having 69%. Okay, which is an absolute overfitting situation, right? It's doing very well on the training. The data it has seen earlier on, but it's doing way worse on the data it has not seen before. Okay, and that is overfitting situation. Now we did something we call pruning, right, which is a regularization technique. Okay, and that is exactly what I am trying to show you over here, right? That is regularization, right? That pruning that we did is a regularization technique, right? We prune the tree, and then we say that the maximum depth that we want is supposed to be 3. Okay, we said the maximum depth that we want is supposed to be 3, and then after that you see that the accuracy improved greatly. Decision tree is one of the algorithms that is always going to, not always, but I would say that 98% of the time is going to overfit. Okay, and you're going to use regularization or pruning to make sure that you avoid that overfitting. Okay, now the other technique that I'm showing you over here is to remove features, right? So later on we saw that we try to see which features are contributing, right, by showing it over here by checking the feature importance. Okay, so we use our model, and then we do dot feature underscore importance, and then we realize that some features are contributing while some of them are not really contributing. So we saw checking underscore balance to be contributing, month's loan duration to be contributing, credit history to be contributing, but you can see some of them are not contributing. They're 0.0000. They are not really contributing. Okay, if you see those that are contributing, checking balance, month loan, you can see them over there. Checking balance, month loan, other credit none, and so on and so forth. The ones that are not contributing, they do not appear, right? But here they were interfering, and that's why we were having, your model was actually overfitting like that. Okay, so now if we build the model on the features that are contributing, and then we take away these ones that are not contributing, right? If they're not contributing, why should they still be in our data, right? So we can just get rid of them and then use only those that are really contributing, right? Like these ones that are contributing, right? We can just ignore all these ones that are not contributing. This one is contributing, this one is contributing. We can add them. This one is not contributing. We can just ignore that. Okay, and that's what I'm doing, right? We are doing feature selection over here. Okay, so let me put it over here, right? I'm just selecting the features that are contributing. Okay, so I'm doing feature selection. Okay, that's what I'm doing over here, right? So if you see over here, I'm selecting checking balance, month loan duration, because that's what is contributing. Checking balance, month loan duration, right? And then credit history, right? So I added credit history. Who else is contributing? Savings balance. Okay, so I added savings balance. And then if you see here, 𝗍𝗱 business is also contributing, right? So I added that one as well. You can see, right, 𝗍𝗱 business, and then you can see other credit none, right? So I added other credit none. These are the ones that are contributing. That's the only thing that I added. Okay, let me actually break them like this so that you get to see. Okay, like that, like that, like that, like that, and like that. So you can see the ones that I've selected, right? You can see them over here. Right, so these are the ones that are contributing. 1, 2, 3, 4, 5, 6, right? These 6 features are the ones contributing, right? 1, 2, 3, 4, 5, and then 6, right? They are the ones that are contributing. We have about 17 features here, but only 6 are contributing, and the rest are just interfering over there. Okay, so I'm going to now build the model again on these 6 features. Okay, so let me run this one. Right, now let me show you what we have. And now I've named the ones that we have selected as new underscore credit data. Our original data is called credit data, so I'm just naming this one as new credit data. Okay, so if I run that one and then I show you what is inside there. Right now we have only checking balance, month, loan duration, credit history, savings balance, purpose, business, and then other credit, none. Instead of all these ones that were earlier on having in our data set that they were just interfering. We have over 17 features over here. Okay, so now let's build the same decision tree on this one. Okay, so now I'm going to split the new credit data, right? I'm just going to split that one into X and then Y. Okay, so I've the X is just the same thing as what we have selected, right? So the target is not here, so I'm just going to call it the X. Okay, and the Y is just the same thing. The Y is what we were. Let's go up here and let me show you the Y. Let's go all the way up. The Y is the default. Okay, the Y is the default over here, right? And we have already prepared that one, right? So if you come all the way down to where we divided our data, right? So we see that the Y is containing only the default. Okay, and that's the same Y, because the Y we don't need to do anything to it. Is the X which we needed to select those that are contributing to help us predict the Y, right? So that's exactly what I am doing over here. Okay, so if you see the X here is just nothing but the same thing that we have over here. Okay, and then the Y, if you see the Y is just going to contain 0 or 1, right? We just whether the person has defaulted. If the person has defaulted, is 0. If the person pay back the loan, is 1. Okay, so I'm just going to split it again, right? And then I'm going to build the decision tree again. Okay, earlier on when we wanted to use the regularization, we set the maximum depth to 3, right? That's what we did in order to cut this one, right? And that's one of the regularization techniques. Now you're doing feature selection, okay, to see which is also another technique to reduce overfitting. Okay, so now I'm going to run this one to build the decision tree again. Okay, now that it has built, now I'm going to check the score again on the training and then also on the testing. Remember earlier on, the original one, when we built, right, on the training and on the testing, we're having 100%, right, and on the testing we're having 69%. So let's see if we're able to solve this overfitting situation. So I'm going to go all the way down here. Right, now we have built the decision tree, so I'm going to now run this one and see if there's any improvement. Now you can see 88 on the training and 71 on the testing. Right, now you can see how close they are. Earlier on it was 100% and 69, and now you can see how we have able to bring it from 69 to closer to the training, which is 88. Okay, the training is going to reduce because this time it's not going to memorize unnecessary stuff, right? And the data is not that containing irrelevant things over there. Right, now you can see that we have been able to solve this overfitting. Okay, so these are the 3 scenarios where also it's techniques that you can use, right? Either you train with more data, or you remove some of the features over there, or you do regularization, right? Like we specify the max depth to be only 3 instead of allowing the tree to overfit. Okay, so depending on the problem statement that you're working on, if your data is the one which is small, you use this one, the train with more data technique. If the features are the ones, some of the features are the ones which are not contributing, you remove them and then use the ones that are contributing, right? If it requires you to do regularization, you know how to do it, right? I've demonstrated it to you, so you know how to do it from now on. Okay, now what I'm going to show you now is how to also deal with underfitting. Okay, so far we have done overfitting, so let me show you how to solve underfitting. Okay, how to prevent underfitting.